Hi everyone, this is R.V. Kiran, Assistant Professor, Department of Mechanical Engineering, Chevrolet Engineering College. Today I am going to discuss a topic on advanced materials, and this is my ninth lecture in the advanced materials subject. And today's topic is classification of FGM, that is functionally graded materials, and types of gradients and the gradients which we are seen in the functionally graded materials. So these are the two topics we are going to discuss in this video lecture. In the last lecture we have already seen about the introduction of FGMs. So why we are seeing the FGMs instead of composites, what is the new class in the materials, what is the recent advanced materials in the composites and alloys, where it came from, that is the origin of the FGMs. So it came from the Japan, which were developed in the 1984-85 result of the space plane project. So we have also seen some of the naturally occurring FGMs, that is skin structure and bamboo sticks and other trees, so other naturally occurring FGMs. Next, we have also seen about the difference between the composite and FGM, and we have discussed about the FGM structure. So we started with the ceramic phase and ended with the metallic phase, and what are the inclusions lead in the transition region and in the matrix region. Then we are going to see about the upper punch and the lower punch die. We have seen the FGM structure also in the multicolor region, and why we are using the FGMs. Now in this video and in this lecture I am going to explain about the classification of FGM. Different types of classifications are there in the functionally graded materials. First classification is the based on compositions and microstructures. So compositions means there are different types of compositions are there: minor composition and major composition of a material. Considering to the alloy, there is a major component of metal, so pure metals are using in the major transition, and minor transition we are using the other materials. But in the composites there are different types of materials we are adding, so as the inclusions, so different types of materials, not only metals, we are including the polymers, ceramics, foams, gels, other etc, fibers, different types of materials. But coming to the microstructures, we have seen different microstructures in the different metals or non-metals, be it a material or metal or non-metal. We will see different types of microstructures there. So comparing to the cast irons only, so when we have seen the cast irons, there are different types of cast irons are there: gray cast iron, white cast iron, chilled cast iron, throttled cast iron. So different types of malleable cast iron, different types of cast irons are there. When we see the gray cast iron, in the microstructure A, dark spots are being enclosed with a white layer, so cement color layer, a dark spots have been observed in the microstructure of gray cast iron. But in the white cast iron, there is a lining of white color layer throughout the material. And going to the chilled cast iron, there is a split pieces, that is the flakes models of materials which we have observed in the microstructures. So first classification is based on these microstructures and compositions only, so that is grading into different types of grades. So there we have seen the different types of classification. Second one is the FGM convert on several types depending their constituents. Constituents means metals, ceramics, polymers, so these are the constants. So carbon fiber and ceramic metal, metal, polymer metal. So different types of constituents are there. So earlier we have seen the ceramic metal composition. So this is the second type of classification here. Next, coming to the third classification, these are divided on the types of gradients or nature of gradients. So nature of gradients, we have divided the materials into four types. First one is the fraction gradient type, second one is the shape gradient, and third one is the orientation gradient type, and last one is the material gradient or size gradient. So these are the four types or four models on the last classification. So we are going to explain about these gradient types in this classification, which is an important one. So based on different vividities of gradients, different types of functional graded materials can be classified as four types. So we have already seen in the last slide also. First one is the fraction gradient type. So going to the first picture, there is a little bit of molecules or atoms on thick on the left side of the picture. But coming to the matrix and coming to the next phases, the thickness of the molecules have been decreased and have been thinner version on the right side. So there is a gradually decreasing of molecules or atoms in the first gradient type, that is the fraction gradient type. So decreasing of atoms or decreasing of the material constituents. And second one is the shape gradient type. So in this gradient type, the size and shape, the shape of the molecules have been changing in the phase. Every phase they have been a different shape. So in the second picture we are seeing first on the bubble type molecule, so bubble type shape, and going to the its second phase they have been changed into somewhat lesser, so compressed model of the first type, and going to the next phase it have been enlarged, elongated as some molecules, and there have been in the next phases they have been elongated into a dark grain size type. So grain size, we have seen the structure of a grain size in the last type on the right side of the second picture, that is the shape gradient type. So shape have been changed enormously in the shape gradient type. And third one is the orientation gradient type. So orientation means change of direction, so that is in the x direction or y direction or z direction. In the three-dimensional axis we are seeing the three dimensions, that is x, y and z type. So here we are seeing the rectangular flakes, so rectangular box type models, which is in the y direction. So assume it in the y direction, and going to the second phase there is somewhat tilting towards the right side and somewhat 15 to 20 degrees tilted towards the right side, and in third phase and 30 to 45 degrees, and in the fourth phase they are continuously changing the direction of flakes, so continuously changing the direction of molecules in the material, and in the last phase we have seen it in the x direction. So change of direction is observed in this type of gradientation, that is orientation gradient type. And last one is the size gradient. So size gradient we will be used to reduce or increase the size of the molecule in the materials. So in the first layer we have seen a large molecule there, and going to the other layers or other areas of the material, other areas of the metal, we are going to see the increment or decrement of the molecules there. So by increasing or decreasing the molecules, we have seen the different types of sections there. So that is the fourth type which we have seen, that is the size gradient type. So next one is the based on the gradation, functionally graded materials have been divided into two types, that is first one is the continuous one and second one is the stepped one. First one is the continuous one and second one is the stepped one, stepped FGM and stepped gradation or continuous gradation. So going to the first one, continuous gradation FGM, we have seen the two phases. So already we have seen the picture in the earlier stage of the lecture. Ceramic phase with combination of the metallic phase. So ceramic phase, starting with the ceramic phase, there is a mild inclusion of the earlier we have seen in the ceramic phase, and second one is the inclusion of metallic inclusions. So inclusion of some metallic layers on the ceramic phase, we are defining the continuous FGM. And going to the transition range, we are mixing with the 50-50% constituents, that is 50% of the ceramic phase and 50% of the metallic inclusions there. And fourth phase is the major metallic inclusions with minor ceramic inclusions, that is the minor part of the inclusions is ceramic, and last one is the metallic phase. But coming to the stepped FGM, there is gradually increasing of decreasing of inclusions here. So going to the right side picture, we are seeing the ceramic matrix there. Next, inclusion of phase 1 and second one is the inclusion of phase 2 there. So there have been multi-phase gradients microstructures there. So in every phase you have seen a different types of microstructure there. So when we are seeing the ceramic matrix, we have seen a first microstructure there. So different microstructures have been observed in the stepped FGMs. Next, we are also seeing the metallic matrix with ceramic inclusions also. In the next slide, we are seeing the example for continuous FGMs, that is continuous gradient FGM. So we are taking tungsten copper as the basic example. So here we are directly seeing the two different layers observed in the continuous gradient. So first one is the tungsten surface and second one is the copper surface inbuiltly done in the tungsten copper gradients. So coming to the tungsten surface, it is higher in hardness and good refractory material. But coming to the copper surface, it is a good electrical and it converts good electrical and thermal conductivity and rebuilds the surface, and it has a good surface finish also. So on the left side of the picture, we have seen the tungsten surface which is somewhat darkish in color, and going to the phases and developing by the phases, it will be reduced and copper surface is exhibit in the final surface of the continuous gradient. So this is the basic example of the continuous gradient. And next one is the example for stepped gradient FGM. We are taking here as mullite molybdenum. So aluminum silicon oxide is the combination of mullite. We are seeing the short form as mullite, and we can also call it as aluminum silicon oxide, and the combination for it is molybdenum. So here also we have changed the phases into different types of phases. So first one is the mullite phase, which we have seen in the mild yellowish color, that is in the mild yellowish color, that is a silver and combination of white. In second layer we are seeing the mild brown color, that is 20% of the molybdenum with mullite combination. And third layer is the 40% volume of molybdenum with mullite combination, and that is 60% mullite and 40% of molybdenum. Next, by increasing the phase, we are seeing the 60% molybdenum with 40% mullite, and last we are seeing the dark blackish color, that is the molybdenum phase. That is the molybdenum phase observed in the stepped gradient of the FGM. So here we are taking the smoother variation favors resistance to the thermal shock. This is the basic formula for the stepped gradient. So when we are taking or furnishing the different types of layers in the molybdenum structure or in the stepped gradient, we are taking here as the basic formula. Next one is the types of gradients. So here we are taking the different types of gradient. First one is the chemical composition gradient. So in this chemical composition of materials, composition varies from one material to the other material, and it results in the different phases of different combinations. So in the first layer we are seeing the tensile property, and second layer we are seeing the compressive property, and third layer we are seeing the hardness property, and fourth layer and we are seeing the other properties. So it is the combination of different compositions in different phases. So the different phases are formed or dependent, so mutually dependent, and compositional quantity and manufacturing conditions are reinforced material, based on the reinforced material. So we are seeing the reinforced material as the minor constants here. Second one is the porosity gradient, and third one is the microstructure gradient. Going to the second one, porosity gradient. So porous means somewhat leakable. So we are leaking some of the minor gradients into other phases. So the functionality of the porosity gradient in the material is to change the is to make the change with the change in spatial position of the bulk material. So when we are seeing the porous objects in the bulk material, so large obtained materials, we are seeing it as porosity gradient. So the size of the gradient can be achieved by varying the powder particle sizes using different locations in the bulking material during the gradation process. So in the gradation process we are seeing the different types of locations, that is different positions or different phases, and the particle sizes can be changed, that is increased or decreased in the micron size. Micron meter, we are seeing it as micron meter in the microstructures. So these are all observed in the microscopes only. So going to the right side picture, there is inclusions of ceramic inclusion with the metallic matrix, and left side one is the bulk material, which is a cuboid, which is in the form of a shape of the cuboid shape. We are seeing the porous materials as light silver color, and dark grayish color is the metallic matrix observed in the porosity gradient. And last one is the microstructure gradient. So from the chemical composition and the porosity gradients, microstructure gradient is somewhat different. So it is achieved in the solidification process, so that after the solidification process the surface of the material can be quenched, that is pouring somewhat sprinkles of the water in the surface, we can be cooled anamata. So a surface మొత్తాన్ని కూడా వాటర్ తోటి క్వెంచింగ్ చేస్తారు. క్వెంచింగ్ అంటే స్ప్రింక్లింగ్ ఆఫ్ వాటర్. కెన్ బి కూల్డ్ ది సర్ఫేస్ అండ్ హీట్ కెన్ బి అబ్జర్వ్డ్. సో ద కోర్ ఆఫ్ ది మెటీరియల్ ఈజ్ allowed to cool down slowly, which could help to produce different microstructures from the surface of the material at the innermost part, that is the core part. We are seeing the core part here as the red color in the left side of the picture. So in the left picture we are seeing the red color core there, but in the right side picture we are seeing the grayish color core here. So the difference between the two objects here is, that is the flow of liquid metal in the left side picture and the flow of cooling water in the right side picture. So that is the major difference observed in the microstructures gradient. So left side one is the in the process of solidification, and right side one is the cooling of the solidification process. By the quenching of water or cooling water, it can be cooled slowly, but in the left side it can be held somewhat of heat pressure in the solidification process. In the recrystallization temperature also we can be observed in the molten metal that somewhat heat is observed in the liquid metal, and by quenching of the water or lubrication we can cool the surface. So these are the types of gradients which we are observed in the FGMs.